In 1950, in his famous essay Times, Computing Machinery and Intelligence*, Alan Turing asked a question that would shape decades of scientific ambition. Can machines think? That question opened one of humanity's greatest intellectual journeys. But 76 years later, in 2026, a more unsettling question emerges. Why do we still need machines to think, when they can already calculate and predict better than all of us? We are living in an era where logic is no longer the sole foundation of intelligence. Instead, data, billions of examples and trillions of probabilistic computations, is rewriting the very rules of programming. This is not merely a technological story. It is the 70-year history of a silent revolution in which humans have shifted from operators of machines to training material for machines. From the 1950s to the 1970s, artificial intelligence was dominated by symbolic AI, an approach grounded in formal logic. Scientists such as Herbert Simon and John McCarthy believed that human reasoning could be replicated through symbolic rules. If humans reason through language and symbols, then teaching machines syntax and logic should allow them to understand the world. Early projects, mathematical problem solvers, chess programs, and theorem provers achieved impressive results within controlled environments. Yet when confronted with the real world, the system collapsed. A program could prove the Pythagorean theorem, but fail to recognize a cat sitting on a table. The reason was simple. Formal logic demands precise definitions for everything. But reality is messy, ambiguous, and full of exceptions. How do you define a chair, a piece of wood, a stone, or even a stair-step can all serve the same function? Symbolic AI fell into a classic philosophical trap. It could describe the word chair, but it had never seen one. This stagnation lasted for decades and became known as the AI winter. The revival of AI began not in laboratories but on the internet. When the global network expanded during the 1990s, humanity unintentionally created something unprecedented, an immense archive of behavior, image, language, and knowledge. By the early 2000s, a profound shift occurred. Instead of writing rules for machines, humans began showing them examples. If symbolic AI was the school of philosophers, machine learning became the school of experience. A model designed to recognize cats no longer required a formal definition of pointed ears, round eyes, or long tails. It only needed millions of cat images, enough data to statistically infer the pattern. The explosion of big data transformed computers into a new kind of entity, one that may not know why something is true, yet consistently knows what is likely to be true. Like a child who cannot define pain, but learns to avoid fire through repeated experience. AI learned through exposure rather than explanation. But the trade-off was profound. AI became a black box. The more accurate it grew, the harder it became to explain. That is the cost of abandoning classical logic. We gain predictive power while losing clear causality. The idea of artificial neural networks dates back to 1958. When Frank Rosenblatt introduced the perceptron. Yet, without sufficient computing power or data, the concept faded into obscurity. The turning point arrived in the early 21st century with the convergence of two forces, GPUs and the Internet. Graphics chips, originally designed to process visual pixels, proved perfect for matrix multiplication, the mathematical backbone of neural networks. Meanwhile, the Internet provided billions of training examples, the nutrients of machine intelligence. As layers of neurons stacked upon each other, each layer learned a different level of abstraction. The first detected edges, the middle distinguished shapes, and the final layers appeared to recognize concepts such as cats, humans, or even emotions. This mechanism roughly mirrors the biological nervous system, where millions of neurons cooperate to abstract patterns from sensory input. The similarity inspired the term deep learning, not because the system is inherently wise, but because it digs deeply into the structure of data itself. For the first time, computers no longer needed explicit formulas. They needed experience. No single genius invented modern AI. It emerged from the convergence of two exponential curves, hardware and algorithms. Moore's law drove processing power to double roughly every 2 years. At the same time, scientists refined machine learning techniques, reducing training times from months to hours. In 2012, the AlexNet model surpassed human performance in image recognition, a historic milestone. From that moment onward, AI ceased to be a laboratory curiosity and became an industry. Today, data centers operated by companies such as NVIDIA, Google, and OpenAI consume energy comparable to that of small nations. Yet what they produce is not physical matter, it is prediction. Artificial intelligence, ultimately, is not the creation of a singular genius mind, but the inevitable result of energy, silicon, and data converging at a single point. A logical machine no longer runs on instructions, it runs on probability. If symbolic AI was the legacy of philosophy, believing the world could be explained through reason, then machine learning is the child of empiricism. Believing the world can only be understood through data, modern AI does not learn the meaning of actions, it learns their patterns. It transforms humanity's history from shopping behavior and medical records to journalism and search habits into an immense training set for predicting the future. And when the past becomes data and the future becomes probability, the boundary between understanding and imitation begins to dissolve. The end of programming's absolute authority, therefore, marks the beginning of a new intellectual order, a world where humans no longer tell machines what to do, but instead struggle to understand what machines are learning from us.